Hello again everyone, Dr. Tom McNamara here, back for our course in trigonometry. In this video I want to go over the angle sum and difference formulas for sine, cosine, and tangent. We will apply those formulas to find the exact value of the trig functions for more angles than we have been able to in the past. If you remember back to some of our previous videos, we can work out the exact value of sine, cosine, and tangent for things that show up in special triangles like 30 degrees, 45 degrees, 60 degrees. We're going to extend what we can do using these sum and difference formulas, and we're going to apply these formulas to proving some identities. So let's get into it here and look at these angle sum and difference formulas. So angle sum, sine of the sum of two angles. The way it works is like this. It's sine A cosine B. Okay, those two are multiplied. Plus cosine A sine B. Alright, so notice it breaks up into two terms, and each of the terms has two factors. It's pretty easy to remember because each of the factors has one sine and one cosine. And if you're talking about the difference of two angles here, then you would take the difference over here. Alright, cosine, on the other hand, this is a little bit different. The cosine angle sum formula is cosine A cosine B. Sine A sine B. Alright, so the cosine formula also has two parts, and each part has two factors, but it's repeated. Cosine, cosine, sine, sine. And the other difference is that if there's a plus here, if you're talking about an angle sum, this is a minus over here. And conversely, if this is a minus, then we get a plus over here. Now, for the tangent, things are a little bit different. Okay, I would recommend you memorize these two right here. These are very handy, both in this course and for those of you that go on to take calculus. These angle sum formulas come up a lot. This one is useful to know, but it's not as important. At least I don't find it as useful. The tangent angle sum formula looks like this. And if this is a minus, then we have a minus up here. Okay, so these are the angle sum and difference formulas. As I mentioned, I recommend memorizing these two. If you're dealing with the sine, you get two terms: sine, cosine, cosine, sine. If there's a plus here, there's a plus there. If there's a minus over here, minus over there. If you're dealing with cosine, you also get two terms. Each term has two factors, and it's repeated. Cosine, cosine, sine, sine. And the plus in the middle here for an angle sum leads to a minus in the middle over here. Okay, so let's keep that in mind as we work some additional examples. So let's do this problem here. We are asked to find the exact value of the cosine of 15 degrees. Alright, so the key step here is to recognize that (15 degrees) is a difference of two special angles. Okay, so cosine 15 degrees, we should think of this as finding the cosine of 45 degrees minus 30 degrees. And the important thing is that we know the value of the trig functions for these angles, 45 and 30. So let's apply the angle difference formula for cosine. So it goes cosine, cosine, so cosine 45, cosine 30, plus sine 45, sine 30, Alright, now cosine 45, I know that. It's radical 2 over 2. Sine 45, also radical 2 over 2. Let's see, let me get the special triangle here, my 30, 60, 90 triangle out here. Remember there's a radical 3 in this special triangle. It goes next to the 30-degree angle. Hypotenuse is 2, and then there's a 1 over there. So the cosine of 30 degrees is adjacent over hypotenuse, radical 3 over 2. The sine of 30 degrees is opposite over hypotenuse, 1 over 2. And we multiply these fractions straight across. And I would say both of these answers are acceptable here. Okay, over here I've multiplied. Radical 3 times radical 2 is radical 6. Remember, square roots behave nicely with respect to multiplication. Here all I did was factor out the radical 2, so just two different ways to write the same thing. Okay, let's do another example. This one is in radians. How do I know it's radians? Well, okay, having a pi there is a big hint, but there's no degree symbol. Okay, if my angle is measured in degrees, there'll be a degree symbol. Alright, so find the exact value for sine pi over 12. And once again, we're going to express this angle as the sum or difference of special angles. Now, if you think about it for a little while, you can figure out that if I take pi over 3 minus pi over 4, well, I'm dealing with fractions, so I'd have to get a common denominator. And if I were to take my common denominator here, it would be 12. Remember, the common denominator has to be something that both this and this divide into evenly. And if you want a number that 3 and 4 both divide into evenly, it's 12. So we're going to rewrite this with a 12 in the denominator by hitting it top and bottom with a 4. And then to get this to have a 12 in the denominator, we're going to hit the top and bottom with a 3. And then we get pi over 12. So we can see pi over 12 is the difference between these two angles. So to figure out sine pi over 12, we are going to treat this as sine of pi over 3 minus pi over 4, and then we are going to apply the angle difference formula for sine. Now you'll remember, we just had it up there. There are two factors in each term, and you get one of each. You get sine, cosine, and then cosine, sine. Okay, once again we're dealing with special angles, so we know what these things are. Okay, sine pi over 3, I can use my special triangles, or look at my unit circle. Sine pi over 3 is root 3 over 2. Cosine pi over 4, root 2 over 2. Cosine pi over 3 is 1/2. Sine pi over 4 is root 2 over 2. Okay, we can do the arithmetic with the fractions just as we did before. It's root 6 minus root 2, whole thing over 4. Okay, so using these angle sum and difference formulas, we can extend our knowledge about the exact values of trig functions. I want to do one more topic here, and that's dealing with identities. Remember, with an identity, we are supposed to prove that we can take one side of our equation and turn it into the other side. So, once again, we will start with the more complicated side, sine of x plus pi over 2. and we're going to apply the angle sum formula over here. So I'd have sine x cosine pi over 2 plus sine pi over 2 cosine x. Now pi over 2 is another special angle. We know the value of sine, cosine, and tangent for pi over 2. Cosine pi over 2 is 0. Okay, if you think very briefly about the unit circle definition, angle of pi over 2 would put us right there. If you're on the unit circle, the cosine of your angle is the x-coordinate. Well, if I'm right here, my x-coordinate is 0, so the cosine is 0. So I have sine x, which is, I don't know, times 0. Now sine pi over 2, that's 1. So we got this over here. And of course now sine x, that's just a variable expression, but 0 times anything is 0. So that goes away entirely, and we're left with cosine x. All right, so the angle sum and difference formulas can also be very useful when we are working on proving some identities, in particular identities that involve a sum or difference of angles.